Hello, IB warriors! Welcome to this wonderful IB math channel, Zintelligence. Whether if you're in IB or if you improve your high school math grade, this channel is the best place for you. So today, we're gonna look at the topic, counting. For many IB warriors, they think counting, this is the hardest chapter among all topics we learned, even harder than calculus or vectors. And I think this is mainly for three reasons. First of all, there are so many question types. So for other chapters, if you do 100 problems, for the next problem, you have a great chance to solve it correctly. However, in this chapter, after you're doing 100 questions, it doesn't really help you much. I know, that's cruel. The second point, I think, is to initiate the question. That's quite challenging. If you did some practice questions before, I guess you will find out that almost all questions from this chapter are real-life problems. To apply your theory into real-life problems, this process is quite challenging for a lot of beginners. So, to choose a correct and the best method for a question, it requires really a strong understanding and rich problem-solving skills. So that's why I've actually seen a lot of students, when they see counting question in their exam, they will just like, look at how disgusting the question is. It's really my pressure to give up and skip it. Okay, and the third reason why I think it's really hard is because the logic behind counting questions are usually very strong and complex. For some other topics such as calculus or vectors, it's really just about concepts and calculation. To understand the concepts is probably what makes those chapters hard. And it is inversed in the chapter counting, because its concepts are really just easy money. What really makes it hard is how do you solve questions, and to maintain a strong logic while thinking which method should I use. So that result in the accuracy of solving counting question correctly is really low, because it's pretty easy to overcount or just forget some cases. However, I'm gonna tell you that you are lucky of clicking into this video, because all of the problems will not be a problem anymore after you watching this series of videos. Okay, so I think it's a good time to step into our main topic today. So, when you hear the word counting, that seems like something for kindergarten kids or for elementary school kids, right? So let's just do some easy, relaxing review first. Please look at this diagram and answer my question. Count. How many apples are there? You have 3 seconds to do the question. Time's up. Hopefully you get a correct answer. It's 8. And now, let's leveling up a little bit. In this diagram, how many bananas are there totally? The correct answer for this question is 5 times 4, which is 20. If you get this right, congratulations, you graduate from the elementary school. Oh well, I know what you're gonna say. That's definitely not the counting we learned in IB. Don't worry, we're gonna move on to next level of counting, which is what we learned in IB. In this diagram, tell me, how many fruits are there totally? You can see this is funny. This is what we learned in IB. This is still a so easy question, but the idea behind this is really the concept of addition principle we learned in IB. So if you really want to tell what's the difference between this one and the previous two, that will be this one, there are 2 types of fruits, and you cannot count total number of fruits at once. Well, if you really want, you can just count 1, 2, 3, 4, 5, 6, 7, but that's clearly not the most efficient method. So a better way we can do this question is we can divide the fruits into 2 cases. In our case 1, that will be banana. We're just gonna focus on how many bananas are there. To count how many bananas are there, you can just use very efficient multiplication here. You get 8. And of course, my second case will be how many apples are there. Still, simple multiplication, we get 3 times 3, which is 9. And we need to do a terminal step to finish up this question. Since it's asking for the total number of fruits, so we need to add each case up together, which we have 8 plus 9, which is 17. Well, here, you think counting is hard? I don't believe that anyone take HL Math will think this is a hard question, right? However, The idea behind this simple counting problem is very, very important. It will be one of your best friends throughout the whole chapter. So this problem-solving idea, we actually have a name. We call that addition principle, or in textbook, I think they call it sum principle. I barely heard someone call it sum principle, so in this video, I guess I'll just call that addition principle. So what it's saying is basically you have whole bunch of possibilities that you need to count, but it is very complicated, or it's pretty easy to make mistakes if you just count how many possibilities are there in total together. So what we need to do is just like the apple and banana question, we can divide the total possibilities into two groups or two cases. Actually, it doesn't have to be two, but just several groups and cases. So maybe here I can have my first group, it's like this group, and my second, like the orange group, and my third group, let's use green. So the next thing we need to do is to focus on each group specifically, and we can count how many possibilities or the unit element are there in each group. So let's say in the purple group I have A possibilities, in the orange group I have B possibilities totally, and in the green group I have C possibilities. So to finish up this question, we just simply need to add A and B and C together. So in summarize, so when you see a situation that it's really hard to count all possibilities together at once, what we can do is break this situation up into several easy cases so that for each case, it is pretty easy or it's relatively easier to count how many possibilities are there. And then just add each case together and we get our final answer. So let's focus on this two steps specifically. So if you look at the second step, it's just adding each case together. That's basically just elementary school level simple addition, right? You shouldn't be struggling with this step. So really, the part that makes the addition principle hard is really how do you divide the case? It's like according to which criteria you break down the case into different classifications. And now I'm gonna illustrate how do you really divide a case by using three examples. They are pretty representative. Okay, so let's see our first example of today. For some questions, the examiners are really kind. They basically tells you that how do you divide a case in the question. So, for example, like in this question, let's read it first, right? How many two-digit numbers are there such that if it's one digit is even, okay? Then its 10 digit is multiple of 3. So, for example, if my one digit is 2, then the 10 digit has to be like 3 or 6 or 9, right? Okay, so that's the first thing. And then, if the one digit is not even, it's odd, then the 10 digit is a multiple of 4. Okay? If my one digit is 1, my 10 digit can be like 4 or something, or 8, right? And your goal for this question is to count how many such a two-digit number are there totally. If you really want to do this question by enumerate every cases down, oh, that works for sure. But is that efficient? Does it increase your accuracy of doing this question? Clearly no. So, this time, I'm a guess, I need to use addition principle. I need to break the case down into several, maybe 2, maybe 3 simple cases. And remember what I said, this question is really clear of how you're gonna divide a case. Because the question literally says, if it's one digit is even, then blah blah blah, and if it's one digit is odd, then what happens? So obviously, our two cases will just be, if it's one digit is even, and if it's one digit is odd. And now, we can focus on these two cases separately. I know that for this two-digit number, if its one digit is even, that means its one digit will be 0, 2, 4, 6, or 8. And let's see what's given in the question. When the one digit is even, its 10 digit has to be like 3, 6, or 9. Only 3 possibilities. So now, we just need to listing down every case we have. So if one's digit is 0, we can have 3, 0, 6, 0, and 9, 0. If the one's digit is 2, we can have 3, 2, 6, 2, and 9, 2. So same thing for 4. We can have 3, 4, 6, 4, and 9, 4. And I don't think I even need to listing down the case for 6 and 8. because you can just predict that they're exactly the same. So, how many possibilities are there? We have 3 columns and we have 5 rows. 3 times 5, we have 15 possibilities. So for the second case, I'm gonna leave it to you and see if you can do this. If you use a similar method and list down every case, you should get 10. So, by now, we've finished up the first step. And the next thing to do is just addition, simple addition, right? We just need to add the 2 cases together, which is 15 plus 10 is 25. So in the question, if you see the word like, if something happened, something happened. So that's basically telling you how to divide the case. And now is the time for the second example here. So before I start the question, I hope you can read it and try to understand and do it. Okay, so let's read it together now. There's a case named Dian is driving from A to B. So it's basically she want to go from this point to this point. And she has a choice of routes which could take her through other towns on the way. The question is asking us how many different routes could Dian take. Assume that she will now return to a town already visited. When we see a counting question, the very beginning thing we should do is try to understand the question. So I'll just give you some example so you can understand the question better. From A to B, one way we can do is we can go from A to B to Q and to B. Okay, that's one way. And some other way we can do is we can go from A to P and to B directly. Okay, but one thing you can now do is you can now go from A to Q and go back to A and go to P and go back to A again, right? That doesn't work. Think about who the hell's gonna do that, right? So, yeah, I hope you can understand the question now. But now, let's think about this. To count how many possibilities are there directly seems like it's hard, right? We can list some situation. We can list like 2 or 3. But how do we know that if we overcount or if we forget some cases, right? So if you just list every situation, it's pretty easy to make mistakes. That's clearly not the best method. A natural flow here is we might need to guess that we need addition principle to break down the cases. And like the first question, in the first example, it's clear that you should divide the case this way. But here, it seems like there's no way I'm gonna know how to divide the case by just looking at the question. Okay, now, I'm gonna share you a secret of solving this kind of question. When you see a counting question that you don't really have an idea how to start, how to initiate a question, one thing you can always do is to try some examples or list down some possibilities. But it doesn't mean you're gonna enumerate randomly. You have to keep your first try and the second try related somehow. Which means the first possibility you list down need to be related to the second possibility you listed down. I know it seems a little bit abstract, but I'm gonna illustrate this by this question, and I think it's gonna be pretty clear. So we can list down the first possibility from A to B. We can go this way, right? And now, I'm gonna list down or find another possibility that's kind of related or similar to the one I just listed. So, to keep this similar, I can keep this part of root exactly the same, and going from A to P in a different way. So now, can you tell me why these 2 ways they're related? You might say that they have a coincident path, but that seems hard to be used as a pattern to divide our case. Are there any other similarities here? You might find that for these 2 paths, they pass exactly the same town. They are both from A to P to Q to B. That's a good pattern, because maybe I can divide a case according to which towns the route passes through. Our case 1. I know that I have to start from A, right? And end at B. So the only thing matters is what's in the middle. So of course I can just go from A to P to B, right? That's my case 1. I can also go from, that's my case 2, A to Q to B. That's my second case. And my third case here, I can go from, from A, right? I can go from P to Q to B, right? And is there any more? Yes, there is. I have my last case. That will be from A to Q, Q to P, and to B, right? I just reverse the order of P and Q, right? Of course, they're gonna be different because, of course, the roots is gonna look different. Okay, so now I have these 4 cases, and I just need to focus on each case specifically. Let's look at case 1. Case 1 is from A to P to B. Let's list every possibilities here. So to make it simpler, I'm gonna simplify this graph. I'm just gonna draw A, P, and B, these 3 points, and forget Q, because that's not in our situation here. So I don't even need to draw that. So from A to P, I have 2 ways. From P to B, I have just 1 way. So let's try to list every case here. The first thing we can do is this way, right? And there's another case is we can go from A to P this way and from P to B. So I know that there are 2 possibilities, or you can say 2 ways. So the second one is A to Q to P. A to Q to B, sorry. So same thing here. I'm just gonna draw A and Q and B. From A to Q, there's only 1 way. From Q to B, there are 2 ways you can go, right? So that means I can have this way, and I can have this way, right? So still I have 2 ways. Okay, and let's look at the third one. It's from A to P to Q to B. So I'm just gonna draw from A to P first. A to P, there are 2 ways, okay? And from P to Q, I'm gonna draw P a little bit here. Okay, so P to Q. Oh, I know, I can see that. Let's see the graph here. From P to Q, there's only 1 way between. So I'm just gonna draw 1 way between P and Q. Okay, next thing, from Q to B. I know there are how many ways? 2 ways, right? So this time, I'm gonna draw 2 ways between Q and B. Okay, so now let's see how many ways can I have. So that seems a little bit more, but let's just try to list everything here. We can have from this. We can have this, right? So the second one we can have from A to P to Q, but I can go downward this side. Okay, so same thing. I can go from A to P downward this time, and go the other side upward. And seems like I have 1 more, right? I can go from A to P. That's a little bit dark. Let's use a lighter color. From A to P, right? From the downward road. And then P to Q, there's 1 way. And from Q to B, I can have downward, right? Okay, so totally that's how many colors we have. We have the yellow one, we have the red one, we have the green one, and we have the blue one. So we have 4 possibilities here. And we have the last one. A to Q to P to B. Same thing. A to P. Let's just draw the graph first. A to Q to P to B. A to Q. That's 1 way between only, right? So I'm just gonna draw 1 road here. From Q to P. Let's see. Q to P. Oh, there's only 1 way, right? So still 1 way. And finally from P to B. P to B. Oh, this gets pretty good. I have only 1 way between P and B also. Okay, so obviously from A to B, I have only 1 choice, right? I have no choice. So that means I have only 1 ways. Whew, okay, we finally finished the casework, and this is our favorite step, which is basically just adding each case together. 2 plus 2 plus 4 plus 1. What is that? That will be 9, right? Okay, so the answer for this question you can see is just 9. So from this example, I just want to show you a very, very commonly used way of solving combinatorics question. When you really have no idea what should I do to start the question, One thing I should always do is to list down some possibilities. And if possible, you should keep your first possibility and the second possibility listed, connected somehow. That could be really helpful for you to find some hidden pattern or some little trick of the question. And now is the moment for the last example of today. And it's the most challenging one. To do a challenging question, I just want to solidify your understanding on the addition principle and how you're going to apply the method I just taught you. So, before I start the question, I hope you can read it yourself and try to solve it yourself. Okay, so let's see this question together. A 3-digit number is an integer with 3 digits. That's just nothing, right? And it has no leading zeros. So you cannot have something like 001. That's not possible. That's not a 3-digit number. Okay, and how many 3-digit number are there such that the sum of its 1 digit and 100 digit equals its 10 digit? What does that mean? If I have 3 digit, let's call that A, B, C. So it's basically saying that A, that's a 100 digit, and C, that's a 1 digit. I add them together, gave me the second digit, which is B. If we use a mathematical way to state that, that will be A plus C equals to B. Okay, so let's have some example here. If I have a 3-digit number with 100 digit 1 and 1's digit 3, according to the question, that will give us a 10th digit of 4. If you think about this question directly and want to list down every case, still, it's possible, but it's clearly not the best way to do it. Now, you might guess that I should use addition principle to help me. But the main problem comes here again. How should I divide the case? Clearly, there's no way I'm going to know that from the question because it doesn't tell me how to divide the case. So similar as the second example, what I do now is to try some examples and list down some possibilities. So we can just randomly write such a 3-digit number. Okay, so the second possibility you're gonna find need to be related or connected to this possibility just listed somehow. So how do I make them connected, or let's say, how do I make them similar? A very natural guess that will be maybe they have some same digits. So let's just guess that if I want to keep my first and third digits the same, what's going to happen? But if you do so, you're going to find that the middle digit has to be 4 because the second digit is basically determined by the first and third digit. So if the 1's digit and 100's digit are the same, the 2 3-digit number are basically the same. That makes no difference. That's not what I want. So this time, I might guess that to keep these two numbers similar, maybe I want to keep the middle digit the same. Okay, so let's see if that helps us to divide the case. If my middle digit is 4, that means the sum of first place and third place, that will be 4. So what I actually need to find is find two numbers adding up together, give me 4. So clearly, I can have 2 plus 2, 3 plus 1, and 4 plus 0. Oh, seems like that's a good way. Because once my middle digit is determined, it is pretty easy for us to list down every cases. For example, if I set my middle digit 5, and can we list down every cases for this situation? Surely we can. We can have 5 plus 0, 4 plus 1, 3 plus 2, 2 plus 3, 2 and 3, 4 and 1, and finally 0 and 5. Be careful here. 0 and 5 is not one of the case because a 100 digit cannot be 0. Okay, so now we have the idea how to divide the case. This question will just become way more easier. So I'll just write down some cases here. I know there are more than 3 cases, but because it's too long, I'm not going to list all of them. And just want to focus on the 3 cases first and see if I can find any patterns for number of possibilities of each case, which can make my life way more easier. So, case 1, when the middle digit is 1, I can just have 1 and 0, right? There's no other possibilities, because we know that a 100 digit cannot be 0. Case 2, If my middle digit is 2, I will have 2 0 and 1 1. So that's 2 ways totally. And then case 3, I can have 3 plus 0. I can have 2 plus 1. I can have 1 plus 2. And that's totally 3 ways. So far, have you found any patterns here? If my middle digit is 1, I have 1 way or 1 possibility. Same thing. If my middle digit is 2, 2 possibilities. Middle digit is 3, 3 possibilities. So I can just guess that for case 4, if my middle digit is 4, I can have 4 ways. In case, let's just check the pattern. So we can have 4 0, 3 3 1, 2 and 2, and 1 and 3, right? So that's exactly 4 ways. Okay, so for the cases after the 4th case, I don't really have to list them all. The only thing I need to find is what is the last case. Clearly, my last case will be case 9, because the highest number in my second digit is 9. I cannot go beyond 9, right? So that means I have 9 ways in case 9. So in total, I want to find how many ways are there totally. I just need to add each case together, which is 1 add 2 add 3 add 4 until 9. Wait. What this is? That's arithmetic series. So sometimes don't be stupid and calculate 1 plus 2 plus 3, this whole monster thing. Just apply arithmetic sequence formula, which is u1 plus un times n divided by 2, which gives us 45 as a final answer. So now we're done this challenging question. So after you're done this question, you can see that that's not really complicated, right? The main thing here is just to find how do we divide the case. And remember, how do we find that? We just try some cases first, right? We just list down some possibilities first, and then find some tricks, find some patterns between, and you can solve this question. So all I want to tell you from these 2 examples, example 2 and example 3, is when you see a question that you have no idea how to initiate, just try some cases. Don't be afraid, okay? Don't be afraid of writing. Your pencil lead, your carbon is not expensive, okay? On your exam, you should use your scratch paper properly and choose the best method and save the most time. Okay, so I guess that's all. That's everything from this video. And you know what? I heard that everyone who subscribed this channel got a 7 in their Math HL exam. So what are you waiting for? Subscribe now and get your 7.